number 5, guys, ask you to compare a T to a Z. Now, remember, when you do your interval looks like this. The mean plus or minus the margin of error. This is the one that makes a difference, your margin of error. So that's why we keep recalculating margin of error. Your mean is exactly the same. So your margin of error dictates which interval will be wider. So in your normal distribution, you can find your margin of error, and in your t-distribution, your margin of error. And again, if you did this with your interval, you can do this in your interval, in your stat test interval. Once you get your interval, just subtract your mean off the higher end, and that will give you your margin of error. So if you want to bypass this, you can. This is what we're looking at. This is the larger margin of error, so therefore it gives you more wiggle room. You have more to and from space. And the reason they do that with the t-score is because your sample size is small, or you don't know enough about your population to be perfectly sure. So they give you a little bit of extra space in there. And that was the goal through most of this exercise. They had you comparing your T and your Z.
This one?
Yes.
When we do this and we get the answer, is it okay if we're like slightly off?
You're rounding. Yeah, it depends how. Well, you should be able to give me your ZC and your TC that way. And the rest you should round it. But how were you off?
I was just off by 0.01.
Did you use the same formula?
Yeah, I got 2.44 for the...
So just be careful of your rounding. That means when you round, look at the next position and round, use your rounding rules. Yeah, just watch when you round. Okay, we didn't do 7, we did 9. Okay, 9 again. It asked for an interval for both of these guys. It said for the T. And then, if you by accident used the Z-score, what would you get? Now, you could see your difference right here. However, here's the thing. If you rounded to one decimal place like the mean, your intervals came out to be exactly the same. Because you rounded. Look where our rounding goes. This also went to 0.2, where the difference really was 0.03 between them. So, if that's the case, I extended this one more decimal point and did your interval so that you would actually see a difference in your interval. I think it was more of a question in, when you do this, what happens when they're that close? Then go out another decimal place. Okay, because they shouldn't have been the same. You know that the T should be a little larger in the margin of error, which gives us a little bit wider interval. When I put your 4.06 and 4.54 here, 409 is actually in here. 409 to 451. So you can see that your Z-square interval is slightly narrower than your T. Put it on the number line because I think it's helpful. Okay. In number 12, they gave you a sample of 7 computers. The mean and the standard deviation. Follow your flow chart. N is less than or equal to 30. They did tell us this was normally distributed in the directions, and they wanted you to find your T interval. So you find your TC, use your degrees of freedom, 1 less than the sample, so your degrees of freedom are 6. Follow your chart, pull out your TC, and use your information. Your margin of error is large. Your standard deviation is fairly large. Your standard deviation was a good size compared to its mean. Had a big standard deviation. So that's what helped us in this case. So now your margin of error. Now if you do this in your calculator, again, take the high one and subtract the mean. This gives you your margin of error. So if you didn't work it out that way and they wanted margin of error, use your interval data. Has everybody tried the calculator? You tried it? I gave you the calculator steps. You like to do by hand? I happen to be a formula person, but I do like the calculator on this one. Can you do? I gave you the calculator steps on the paper. Go to stat, go to test, and go to T interval or Z interval, and then go to stats on the not the data stats, and then put your information in.
If we do that on the test, you want us to just...
I just want your step, because what happens is if you do a T and not a Z, and I don't see it, everything is wrong. So I need to see what you put in. Yes.
It was 95.
It's 95. But degrees of freedom is 6. Your TC uses DF on the top. DF. It uses your DF. Okay, number 14, guys. You did some research, and they want you to repeat exercise 12, knowing your standard deviation of your population. That's one of the things in your flowchart. If it was less than or equal to 30, yes. Normally distributed, yes. But if you know your population, you can automatically use your Z. That's because you know enough about previous information. Guys, I have 5 minutes. Don't pack it up. So use this again using your Z interval.
Wait, why do you use Z again?
Because this time they told us they know your population standard deviation. So in your flow chart, it'll say n is greater than or equal to 30. You say no. Is it normally distributed? Yes. Do I know my population? Then I got to go use my Z. Just follow your flow chart. So you know enough about your population to count on your Z score. The reason you use a T is to give you a little bit more wiggle room because you didn't know enough about your population and you didn't have that large of a sample. But in this case, you do. Don't forget to find your ZC, your critical value. And again, you can use your calculator for this. So we should see that this gives us a little bit narrower than that one. The T is a little wider. In 15, we have a random sample of 10 standard deviation. So you did it with your TC, and then they said, assuming that it came from a sample size of 500, not 10. So 500 says you're greater than or equal to 30, use a Z. So a Z for a 90% confidence interval gave us this information. And you can see right here, look at the difference right here, guys. How much smaller your margin of error is as your sample size got larger. As your sample size got larger, your margin of error got smaller because you were more confident about your population that way. So you didn't need as much wiggle room as your sample got larger. There's a lot of things built into this. Okay? Number 19, this was a good calculator one. To put it in your calculator, do a one-bear stat, get your mean, get your standard deviation. Then construct this, and you're going to use your population is normally distributed. Again, we're 99% confident that our population mean will fall between 635.4 and 1182.8. You guys all got this? Okay. Let me just whip through 21. Yes, you can use your Z-score. You had 70. 22, a random sample. Use your T. Okay, you only have 12, and you don't know anything about your population. And one last one. This one, you couldn't do anything. Not normally distributed.